Welcome back, everyone. So we're going to continue with part 2 of lesson 1, wherever we left off. And here we go again. So we're going to discuss in this part what is happening to the values of b. Okay, so we noticed that in the first part, x could be either positive or negative or 0. So we said that x can practically be any real number. Okay, so but how about the values of b? Because we only saw values of b of 2 and 1/2, so only positive numbers. So we're going to look at some special values of b as a matter of fact. So we're going to look at b equals 1 and b equals 0. As a matter of fact, in an exponential function, b is not allowed to be 1 or 0. I didn't mention this at the beginning because I wanted to break the lesson down and take things one at a time, but let's take a look at this now. So if b equals 1, then the exponential function will become, from b to the power of x, 1 to the power of x. And we know that number 1 raised to any power will give 1. So f of x equals 1 will be the exponential function that we had in here, y equals b to the power of x, right? So when you look at this one here, this is not an exponential function anymore. This will be a linear function. And not just any linear function, it will be a horizontal line, right? So that is the reason why we say that b must be different than 1. Now, what's going to happen if b equals 0 then? Again, same reasoning. So we're going to say f of x equals b to the power of x, or 0 to the power of x. So we're going to have f of x equals 0. So that's not an exponential function again. This is a linear function, and even more, it's a horizontal line, so it's not exponential. Now, we discussed the values of b equals 1 or 0. Now, can b be a negative number? So can b be negative? So by convention, we have decided to only look at exponential functions where b is a positive number, not a negative. So for now, we are going to say that b cannot be negative. So in general, as I mentioned at the beginning of the lesson, then an exponential function can be written in the form a b x minus h kx minus h plus d. Now, I actually mentioned that just for clarification, so we call this coefficient here d. That's what we have used in the Nelson book, and this coefficient c, so it doesn't really make much of a difference. It's how we name them, but we all understand that this is the horizontal translation and this is the vertical translation right there. Okay, so if you would like to, you can just write a few notes for yourself about the how the coefficients will affect the shape of the graph. So we're going to say that a, right? And remember how we drew the line at the beginning of the year with all the values of a, and then the values of k, and then the values of h, I'm going to call it as it is indicated in there, and the values of d as well. Okay, and sorry about that, so I'm just going to make it straight. Okay, so we said that I'm going to mark the 0 in each end, and for the coefficient k, I'm also going to mark the 1 and negative 1. And we're going to say that for the values of a bigger than 1 or less than negative 1, we have a vertical expansion, and in between these two values, we have a vertical compression. So the graph will become 2 times shorter. Now, similar to this, we looked at coefficient k. We said if it is bigger than 1, less than -1, that's a horizontal compression, meaning the graph will become narrower. Okay, the height will not change. Okay, and in between -1 and +1, that's when we have a horizontal expansion. Now for the values of h, we're going to say that we have horizontal translation to the right, horizontal translation to the left here. And for values of d, we're going to say bigger than 0, vertical translation up, and vertical translation down. Okay, so I'm going to illustrate it with a couple of examples. With a few examples wherever necessary. So I'm going to say if you have, let's say, y equals 3 times 2 to the power of x, that would be a vertical expansion. Or y equals -3 2 to the power of x, that's again a vertical expansion. Vertical compression is if you have y equals 1/5 times 2 to the power of x, right? For horizontal compressions, y equals 2 to the power of 3x. That would be narrower, so the height won't change, but the width will. And y equals 2 to the -3x. And an expansion will happen when we have a function in the form y equals 1/3 of x to the power 1/3 x. Now, horizontal translation is when you have y equals 2 to the power of x minus 4, so that's 4 to the right, and y equals 2 to the power of x plus 4, so that would be 4 to the left. And the vertical translation is the easier one to understand. So this is the second part of the video, and I'm going to record the next, the rest of the lesson in another video.